Hello, everyone, and you are welcome back to my online teaching platform. We have a question here which relates to limit of functions. Limit of functions. So let us look at how best we can answer this question. We have a function g of x equal to 3x minus 1 or divided by x minus 2. So the function g is a polynomial, sorry, it's a rational function. The function g is a rational function. So let us identify the questions that follow. The first question here is to express the given function in the form a plus b, where b is divided by x minus 2. So it means we are to express it as a partial fraction, where a is the quotient, b is the remainder, and x minus 2 becomes the divisor. So that's what we are supposed to do first. So the function here is 3x minus 1. Let me write the function first. So the function g of x is equal to 3x minus 1 or divided by x minus 2 or divided by x minus 2. So it means we have to divide the numerator 3x minus 1 by x minus 2. So we need to use the long division approach. So we are going to work with that particular method. So it means our x minus 2 is the divisor. So you put here x minus 2 here nicely. Then inside the radical sign, you put 3x minus 1 here. Then we can now divide. So this is what you are going to do. When you have when you have a rational function in this form and you are to divide, let us look at one key thing over here. You could see that the coefficient of x here, this particular one, the coefficient of this x is 1. That is the leading term is 1, and that of this one is also 1. So it renders the rational function improper. Yes, it makes it improper. So you need to divide. The moment they have the same power, their leading terms have the same power, it means it is an improper rational function. If the power of the leading term of the numerator is more than that of the power of the leading term of the denominator, is also an improper rational function. So, but when the numerator has a power less than that of the denominator, it becomes a proper rational function. But looking at this is an improper rational function. So that is why we need to divide so that we can get it as a mixed fraction. So you could say they have to express it in the form a plus b divided by x minus 2. So that's what we are coming to do here. So you are look at the x, we are going to use the leading term of the divisor to divide the leading term of the dividend. The numerator is what we call the dividend. So when x divides 3x, we are going to get 3 over here. Then whatever you are getting, you use that value to multiply each of the terms in the divisor. So when you multiply 3 by x, you are going to get 3x. Then you put it under the dividend. Then you continue to multiply the negative 2 here also by what you have obtained over there. That is the quotient, the one you have obtained over here. So we are going to get negative 6. Then you underline nicely. So we are going to subtract this to get a remainder. So we subtract this from the first expression. So 3x minus 3x will give us 0. So here becomes 0. Then negative 1 minus negative 6, it becomes negative 1 plus 6. So we are going to get here to be positive 5. All right. Now you could see that, all right, you could see that what we have here is now 0 plus 5, and that will give us, so we are getting a remainder of 5. Now you could see that 5 can be written as x exponent 0 multiplying 5, which is the same as 5. Now when you look at the power of the x over here, this power is 0, but the power of the x over is 1. So the moment the power of the x of the leading term is less than the power of the x of the leading term in the divisor, there's no way you can divide again, since the power of the remainder over here, you see that the power of the x in this particular remainder is 0. The power of the xy is 0, and the power of the divisor here of this particular x is 1. So there's no way you can divide, or you can continue to divide. So our remainder becomes 5. So it means when you divide 3x minus 1 by x minus 2, you'll be getting 3 as a quotient, as a whole number with a remainder of 5. So anytime you have a remainder, it means you still need to divide the remainder. So it's going to be 3 plus 5 divided by x minus 3. So our 3x minus 1 divided by x minus 2 will be equivalent to 3 plus 5, which is the remainder, then divided by the divisor again. This is the same as, suppose you are dividing, so let's say you have a number, let's say 5, you are dividing 5 by 2. If we say that the fraction is an improper fraction, so we can divide 5 by 2 to get a quotient of 2, a whole number. So the whole number will be 2, and we'll be having a remainder of 1. So the remainder, we write it as 2 whole number 1 divided by 2, or 1 half, which is the same as 2 whole number plus 1 divided by 2. So you can see that the 2 is still here, which is the same as the divisor over here. So the same thing is applied to this. So you can see that since this is the divisor and we have a remainder of 5, we are going to get the divisor still dividing the remainder, which is the 5. So we conclude that 3x minus 1 divided by x minus 2 is equal to 3 plus 5 divided by x minus 2. So this is the answer for the first part. That's the question A. Let us look at the B part of what we are doing. So the B part is saying that hence find the limit of the function g of x as its input approaches infinity. As its input approaches infinity. So that's the B part of the question. All right. So we have to find the limit of the function as its input approaches infinity. So we have to evaluate. This is the B part of the question. So we have to hence find the limit of g of x as the input approaches infinity. So let us look at how best we can get the answer. So we just replace the g of x with its component. So this becomes the limit of 3 plus 5 divided by x minus 2, because g of x is the same as 3 plus 5 divided by x minus 2 as the input x approaches infinity. So this is what we are supposed to evaluate. So we are going to get, so now we can plug in the value of infinity. So we are just going to plug in we are going to plug in the value of x, which is infinity. So let us look at how best we can get the answer. So we are going to get 3 plus 5 divided by infinity minus 2. So we continue to evaluate. We are going to get 3 plus 5 divided by infinity minus 2 will give us infinity. So at the end, we are going to get 3 plus 5 over infinity. So, and this will give us 0. So we are going to get the final answer to be 3. Hence, the limit of g of x as the input x approaches infinity is equal to 3. Thank you for watching, and don't forget to like and share.